Okay, good morning, Cappuccino. It is Asynchronous Wednesday, and here's a helper video to help you with today's homework on page 613. So here we are combining probability distribution problems. So the first one we have is we have a cookery book is translated from Russian into English. Each page has two separate sections, ingredients and method, which are translated by different translators working independently. Assume the number of translation errors in the ingredients section and the method section follow a Poisson distributions with parameters 0.7 and 0.6 respectively. Find the probability that on a given page there is at least one error. So it looks like the first section, ingredients, has a parameter of 0.7. So that's perhaps like 0.7 mistakes per ingredient section. And then there's 0.6 of a mistake per page for the methods section. So it looks like the person who is translating methods is perhaps a little bit better than the person who is translating the ingredients. But now we need to figure out, well, what's the probability that any given page is going to have an error? So what we saw in the video is that when you have this Poisson distribution, all you have to do is add the two lambdas together. So I have my first Poisson distribution for the ingredients part has a lambda of 0.7, and the other part for methods has a lambda of 0.6. So all we have to do is take those two values and add those together to get the probability, or to get the distribution, I should say, to get the distribution of errors of both of them together. So if I add 0.7 plus 0.6, I get 1.3. So this means that on average, there's 1.3 errors per page in this cookbook. Okay, so on average, there's 1.3 errors per page. So find the probability. Okay, so our random variable is distributed as a Poisson distribution with a lambda of 1.3. Now we want to find the probability that there is at least one error. So that's one error or greater. So I want x to be greater than or equal to 1. So now if we go to our calculator, I can't remember. I have a terrible memory, so I can never remember, is this one where we have to do the 1 minus? I'm going to be able to figure that out when I actually look in here. So I'm going to go second, distribute, and I want the Poisson, and I want CDF because I want cumulative because I have a inequality. Oh, see, notice it doesn't like give me the maximum and minimum thing. I'm pretty sure that's only for normal distribution. So I'm going to have to rewrite this, because when it doesn't give me, the upper and lower limit, then that automatically means that the default is that it's going to give me a less than. So I'm going to rewrite this. I'm going to want, if I want greater than or equal to 1, the complement of that would be x is less than 1, which would be just 0. So I'm actually going to put in 1 minus the probability that x equals 0. You can't have anything negative in a Poisson distribution. You can't have a negative number of errors per page. So I'm going to do this instead. So I'm going to put in for my lambda is 1.3. My x value is 0. I want to know what's the chance that there's no errors. And enter, 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 and I get that. And now I need to subtract that from 1. And I get my answer. So the probability that there is one or more error is going to be 0.727. Okay, so we just had to combine our lambdas to get our new lambda and then put it into our calculator. Again, just like solving any other Poisson distribution problem. Have to figure out, do I need to use the complement or can I put it in as it is? I couldn't put it in as it is. I had to use the complement in order to get my answer. All right, that's problem 1.